Hello, everyone, and welcome. My name is Sabrina Di Bartolomeo, and I will be your moderator today. I'm a FastTrack solution architect, and today's session is about ALM best practices. A quick look at today's agenda. We will start with the basics of ALM and why it is important. Then we will talk about environment strategy and governance, followed by solution strategy and best practices. Next, we will look at source code integration and how to treat solution as code, including a demo. We will then review the main deployment tools and options available today. At the end, there will be time for a Q&A session. What is Application Lifecycle Management or ALM? And what does a good ALM strategy include? When people hear ALM, they often think about moving solutions between environments. A common approach is I'll build everything first and figure out how to move it to production later. And that's where teams usually get stuck because ALM ends up being treated as a technical problem instead of part of a project strategy. ALM stands for Application Lifecycle Management, which means that it should support the entire life cycle of the project. It should start during project planning, how work is planned, requirements are managed, environments are designed, changes are tested, releases are done safely, and more. By the way, if you implement Dynamics 365 products, there's a useful resource you can take advantage of: the Business Process Catalog. It's a DevOps template that lets you import predefined business processes directly into DevOps to generate epics, features, and user stories. You'll find the link to it in the documentation slide included in this presentation. As mentioned, ALM is a cycle. Because projects evolve, ALM must be flexible. Your environments, releases, and processes may need to adapt as requirements and team change. Things to consider for your ALM strategy. Environment strategy. How many environments are really needed? In which region? App strategy. Is the workload focused on a single app, or does it span multiple apps such as sales and customer service? Team size and skills. Consider the size and experience of the team, of the implementation team. Some projects involve only a few citizen developers, while others include larger teams with DevOps know-how. Another key aspect is long-term ownership. After the partner steps away, the customer still needs the skill to manage the platform, maintain customization, and adopt new features internally. When the skills are limited, establishing a center of excellence and investing in training is often the right approach. Release planning. Consider how releases are planned and delivered. Is the work done in sprints? How often should changes be released to production? What is the approach when a production bug needs a quick fix, but new features are not ready to be released? An ALM strategy depends on all these factors. It also includes the tools and processes used to manage it from start to finish. The takeaway is there's no one perfect ALM strategy, but when it is defined early and aligned with how the project is run, everything that follows becomes easier, safer, and more predictable. Why is ALM essential for organization, and what are the common challenges solved by ALM? A quick note before continuing. I won't go over the basic you already might know, like the differences between managed and unmanaged solutions. What I will cover are recent updates, modern approaches, and new features that can really make a difference today. There's already a good ALM documentation available on Microsoft Learn. Individual products such as Power Apps or Copilot Studio also include their own ALM recommendation on their Microsoft Learn web pages. They are written mainly from the point of view of that specific product. However, the primary ALM documentation for Power Platform and Dynamics 365 projects is available at the link shown in the slide. This said, it helps to briefly clarify why ALM matters. Simply said, we often understand the value of ALM only after something goes wrong. And I'm sure many might recognize a few of the situations. It worked in tests, why doesn't it work in prod? This is a very common one. Everything is tested, tests pass, and then production behaves differently. A solid ALM process reduces this risk by ensuring that what gets deployed is exactly what was tested. Something was deployed by mistake. How can it be rolled back? When unmanaged solutions are used also in test and production environments, rolling back changes becomes a manual and time-consuming task, repeated environment by environment. With a proper ALM, deployments are safer and rollbacks are controlled and predictable. Unmanaged solutions should exist only in development environments. There's absolutely no reason to do it any other way, only disadvantages. Using unmanaged solution only in dev is not just a recommendation. It is the only approach that consistently brings benefits rather than problems. Someone changed something directly in prod. Now what? Changes should never be made directly in production. When this happens, let's say by mistake, a healthy ALM makes it much easier to identify what changed and to fix the issue quickly. And one more that deserves a special call out. A development environment must be recreated exactly as it was at a specific point in time. A healthy ALM strategy makes this possible. You can always just rebuild a development environment directly from source control. Let's talk now about Power Platform environments. One of the first decisions to make is choosing the right environment strategy. There's always one key question you need to answer early. How many dev, test, training, data migration, and prod environments are actually needed? This isn't just an operational detail. It directly affects the scalability and long-term health of the implementation. Every environment comes with infrastructure, licensing, and support implication. Critical is to decide how many development environments are needed. If multiple developers or teams are working on different features or modules, having separate dev environments prevent them from overwriting each other's work or causing conflicts. Region of environments. If the organization operates in a single region, all environments should be in the same region. Having dev in one region and test or prod in another should be avoided. When environments are in different regions, Dataverse updates are applied at different times. This can result in a warning during import, such as this solution was exported from an environment with a more recent version of Dataverse. Although this is only a warning and the import can continue, in this situation, the solution might reference components that the target environment with an earlier, lower Dataverse version doesn't have yet. This, in most cases, happens when Microsoft tables are added entirely to a solution, instead of including only the components that were changed or created. In such cases, the solution may take dependencies on components introduced in a more recent version of solutions that is not yet available in the target environment. A similar issue can happen when new Microsoft solutions are installed in a development environment only to test new features, but are not installed in test or in prod. This is considered a bad practice. For evaluating new Microsoft features, a dedicated environment is recommended. Some customers use an early first release environment for dev, and this is considered a bad practice for the same reason. There are, of course, international customers that have a dev environment in one region and import the same solution into multiple environments having different regions. In this situation, it may make sense to place the development environment in a region on a lower update station, receiving Dataverse updates later. A link to the detailed article explaining this topic is included in the documentation slide. Environment governance. Environment governance is about setting clear rules for how Power Platform environments are created, used, and managed. Key questions a Power Platform admin should ask are: who is allowed to create environments? How to automate the creation of environments? How to enforce security? How to monitor usage and costs? To simplify the governance, managed environments could be used. Managed environments is a set of premium capabilities to enhance security, governance, and operation features for Power Platform environments at scale, with more control, less effort, and more insights. I will not deep dive all features of managed environments. I just want to mention 3 features that are available only in managed environments. Environment routing. It ensures that when makers or developers access make.power apps or Copilot Studio, they are routed to the correct development environment instead of the default one. Power Platform Pipeline is a built-in way to deploy solutions from dev to target environment, and source control integration that connects Power Platform solutions directly to a DevOps Git repository. Next topic is solution strategy. A common question is, how many solutions should be created? The honest answer is always the same. It depends. For medium complexity projects and medium-sized teams, using just one solution for everything is usually a good choice. In the past, multiple solutions were often created for practical reasons. Because of solution import timeouts, solution size, solution file size limitations, the need to deploy only a subset of components to a target environment. But the platform has evolved, and many of these are now legacy best practices. In many modern projects, working with one solution is no longer an issue. Platform improvements have made solution imports faster and more reliable, and most of the old limitations no longer apply. When the right settings are used, only the components that changed since the last deployment are imported. And this makes the import of the solution much faster. These settings are explained in more detail in another slide. And because of these improvements, also patches are no longer recommended. Patches were introduced 7 or 8 years ago, and by then it was the only way to deploy something fast. Now importing managed solution using the update option is as fast as using patches. So the advantage is gone. Working with patches is complex, especially if you do integration with source control system, because patches are independent solution and it gets complex, really complex to understand the source of truth if patches are used. So patches are making things extra complex for no net benefit. A modular approach is also an option. In this case, multiple solutions are used, each with its own dedicated development environment. In some use cases, there are valid reasons to work with multiple solutions. Today, this choice is less about working around solution limitations and more about managing the complexity of what is being built. In enterprise projects, flexibility is often required because large implementation teams work across different business areas. How does a modular approach work? Usually, this means deploying a base managed solution first in a new separate development environment, and then adding an unmanaged extension solution to further extend. Extension approaches are driven by different use cases. A common pattern is an app-based extension model, where a core solution contains common tables, business processes, security, role integrations, while another separate solution extends specific applications such as sales or customer service. Another common use case is industry-based extensions. In this case, the core solution provides generic business capabilities. An additional solution adds industry-specific logic, for example, healthcare entities and workflow, or retail pricing and promotions. A third use case might be regional extension for global organizations. Here, one core solution is used across regions, while regional solutions handle local requirements such as tax rules, country-specific fields, languages, or compliance needs. A common mistake is creating multiple solutions in the same development environment with the intention to isolate changes. This does simply not work because solutions only reference components in the environment. They do not create copies. Any change affects the environment itself. Multiple solutions in the same development environment are also sometimes used under the assumption that deployments will be faster. This approach is responsible for many implementation issues since it creates dependencies between the solutions. And there's the risk to accidentally create cyclic dependencies that prevent solutions importing. Multiple solutions should exist in the same development environment only when they don't share components and functionalities of the solutions are clearly separated and deployed independently, such as standalone apps or isolated agent solutions. There's currently one known gap, which sometimes leads to the recommendation of using a dedicated second solution. Custom connectors. Connectors must exist before connection can be created, which sometimes require deploying them separately first. In practice, this means either deploying the solution once without configuring connections, just to create the connectors, and deploying it again later with the connections, or keeping custom connectors in a separate solution that is imported first, while connection references remain in the main solution. But as I said, this is a gap for now that we hope to get closed up soon. The key message is don't over-engineer the solution strategy. Keep the solution strategy as simple as possible. Fewer solutions mean less complexity and easier environment management. Let's talk now about the publisher. The publisher is not just about defining a prefix for components, as many think. It plays a key role in solution design and ALM. Choices made at this stage have long-term consequences and are very hard to reverse later. When a managed solution is imported into an environment, the publisher of that solution becomes the owner of all its components. What does it mean? The owner of a component controls which changes other publishers are allowed to make or are restricted from making on that component. This is why Microsoft components cannot be deleted. Only the Microsoft publisher in the unmanaged layer has the permission to delete them. In some cases, Microsoft allows other publishers to update things like labels or selected properties or adding columns and forms. When solutions are delivered to other organizations, as an example, an ISV, independent software vendor that sells applications by providing managed solutions, some level of customization is often required to meet local needs. At the same time, long-term support and stability depend on protecting the components that contain core functionality. Managed properties can be used to control which parts of a managed solution can be customized by another publisher. More info regarding managed properties are available in the documentation mentioned in this slide. Some projects run into problems because multiple publishers are created without fully understanding the impact. Production environments then end up with many managed solutions, each using a different publisher. When teams later try to simplify or merge the solutions, this often turns out to be impossible. The lowest number of managed solutions that can exist is always equal to the number of different publishers. The reason is simple. Components can only be moved between managed solutions if both solutions use the same publisher. And if publishers are different, the component must be deleted first and then recreated. And once a component already exists in production, this also means data migration, which adds significant complexity and risk. For this reason, using a single publisher across a project is considered a best practice, unless there's a clear reason not to. This keeps solution layering flexible and avoids expensive redesign work later. The more publisher you have, the more solution layers you have. So the real issue is the cost of merging across multiple solution layers. One of the main reasons why solutions are big and take a huge amount of time to import is the lack of table segmentation. Segmentation means including in the solution only what is new or has changed. When a Microsoft table is added to a solution in order to create, for example, new forms, new columns, the option Include All Objects should never be selected. This option may only make sense for custom tables, not for standard Microsoft tables. An option that helps applying the right table segmentation is using the preferred solution. A preferred solution is the main solution that adds automatically all components that has been changed or created. More info are available in the documentation mentioned in the slide. When include table metadata is not selected, the table settings section visible on the right side of the slide will not be part of the solution. And for that reason, changes done to the settings will not be transported to the target environment. But if the table was already added to the solution without this option, this settings can still be adjusted later in advanced table segmentation properties. Here's a quick, simple summary of what has been covered so far, with a few additional recommendations. Consider, if possible, having only one solution. Do not create a solution for each sprint. If working with multiple solutions is necessary, consider a modular approach, having a dedicated development environment per unmanaged solution. Avoid multiple unmanaged solutions in the same environment if they have dependencies. Create a custom publisher for the project, and if multiple development environments are created, use the same publisher for all the development environments. Always work in a solution and consider the option of using a preferred solution. Only include in solution components that are being changed or created. Never add a Microsoft table with include all objects. Use unmanaged solutions only in development environments. Don't use patches. Use the import with update option instead. Run solution checker to validate solutions. Let's talk now about the benefits of source code integration. As mentioned earlier, the value of a healthy ALM approach is often only realized when something goes wrong. There have been projects where, after go live, teams deleted the development and test environments and kept only production. The idea was that development could always be recreated by cloning production. But that doesn't work. To rebuild a development environment, the unmanaged layer of the solution and of its publisher are needed, and both of them are not existing in production. This is why keeping environment consistently tracked in source control is such an important best practice. A Power Platform solution is not just a configuration artifact, it is code. What are the main benefits of storing the source code of a solution in a code repository? First, the version history and traceability. Every change to the solution is tracked. This means you can see who made what change, when, and why. If something breaks or needs to be reverted, you can easily roll back to a previous version. Collaboration. Multiple developers can work on the same solution at the same time. Source control system helps manage changes from various contributors, making it simpler to merge updates and handle any conflict. Code quality and review enable pull requests and code reviews before changes are made, improve quality and catching issue earlier. Backup and disaster recovery. The solution is safely backed up in a repository, protecting against accidental deletions or corruption in the Power Platform environment. Audit trail and compliance. Maintaining a history of changes is crucial for auditing and compliance. Source control provides a clear record of all modification, which is especially important in regulated environments. Keeping the Power Platform solution and source control as the source of truth of the solution is a best practice for any professional development team. The source control integration functionality is available natively in the solutions experience. It allows development teams to sync unmanaged solutions and solution components with a DevOps Git repository. I won't go into details on how to enable it. Detailed instructions are available at the Microsoft Learn webpage mentioned in the slide. Since a solution is code, the traditional software development process can also be applied to solutions as well. Nearly every source control system has some form of branching and merging support, and each implementation team chooses the branching strategy that works best for them. It is important to remember that if a multiple solution approach is used, the same branch strategy must be managed for each solution, and this increases the effort of tracking changes and testing. Working with a single solution keeps ALM simple. Next, a demo will showcase one of these branching strategies.
Let's start with the repository. The main branch is empty. The main branch represents the production environment. At this point, the project is not live yet, so there is no production code available. Work is organized into releases to structure the development process. Each release is broken down into sprints. Within each sprint, specific features are developed and delivered. All changes made during development can be tracked and linked to a work item, such as a user story or a task. This makes it easy to understand why a change was made and what business requirement it supports. For this demo, 2 features have been created to show how work can be done in parallel. At this point, 2 development environments are already available, Dev01 and Dev02. A solution named Customizations exists in both development environments and uses the same publisher. This approach ensures consistency across all development environments. To achieve this setup, after the publisher and the solution are created, the empty unmanaged version of the solution is kept as the development baseline and imported into every new development environment. This guarantees that all environments starts with the same solution and the same publisher. The first development team is working on the user story, account, and contact. To start, they connect the Dev01 environment to a dedicated Git branch called Feature1. In parallel, a second development team is working on a different user story that requires customizations on the case table. This team connects the Dev02 environment to another branch called Feature2. By connecting each development environment to its own feature branch, the 2 teams can work in isolation, without impacting each other. Each team makes changes only on its own branch and commits the work independently. This approach allows development to happen in parallel, keeps changes clearly separated, and makes it easier to track, review, and merge the work later through pull requests. The development team on the left starts working on the first user story by adding the account table to the solution. Because account is a standard Microsoft table and not a custom one, the option Include All Objects is intentionally not selected. Instead of pulling in everything, only the required components are added to the solution. This keeps the solution clean, avoids unnecessary dependencies, and makes changes easier to track later when working with Git and pull requests. At the same time, the second development team works on a separate user story. Their focus is on the case table. They add the case table to the solution, again making sure that Include All Objects is not selected. Only the specific components required for this scenario are added to the solution, such as the forms or views that are actually needed. This approach keeps the solution clean and avoids bringing in unnecessary dependencies. Both development teams continue working on their customizations, making only the changes required for their user stories. This includes updating fields, adjusting forms, and adding any additional components needed for the scenario. At this stage, the solution reflects a clean and stable state. Once the work is complete and validated, the teams publish their changes. After publishing, the changes are ready to be committed to the Git repository. For both teams, this is the first commit in the project. The branches they are connected to are still empty, so no changes are available yet. The first development team commits its work to its own branch, adding clear and meaningful commit comments that describe the changes made. The second development team follows the same approach on a separate branch, committing only the work related to its feature. Because the teams are working on different branches, their changes are isolated. Each team works independently and does not see the other team's changes until the work is later merged through pull requests. After a successful commit, it is possible to navigate directly to the source control system. As shown, the solution is stored in YAML format, which is more human-readable and easy to understand. Next, pull requests are created to bring the work together in the Sprint 1 branch. The first development team opens a pull request to merge the changes from Feature 1 into the Sprint 1 branch. In parallel, the second team also prepares a pull request to merge its work from Feature 2 into the same Sprint 1 branch. The development team on the left completes testing first and receives approval for its pull request. Because of this, the pull request for Feature 1 can be completed first and merged. Feature 2 is merged right after. Since feature 1 is already in the Sprint 1 branch, the second pull request now detects conflicts between the two changes. Conflicts can occur, for example, in the missing dependencies file. This happens because the solution is shared and changes from multiple development teams affect the same solution structure. The first development team is working on the account and contact tables, so the required missing dependencies for these tables are added. The second development team is working on the case table, which introduces additional missing dependencies that also need to be included. These conflicts must be reviewed and resolved before the merge can be completed. Conflicts could be resolved in source control manually. Automatic conflict resolution tools are not recommended, as they typically add conflict-related comments to the source code that cannot be serialized. One way to avoid conflicts is to update the Dev02 development environment with the Sprint 1 changes before creating the pull request. This can be done by first disconnecting Dev02 from the Feature 2 branch, then connecting it to Sprint 1 to pull the latest updates, and finally reconnecting the environment back to Feature 2. Once the conflicts are resolved and the merge is completed, this is how the Sprint 1 branch source code will look. It will contain all the customizations from the different features, but it will always follow the structure of a single solution with a single publisher. At this point, a pipeline can deploy the solution to the target development environment.
Next, an overview of the available deployment tools. The choice of which tool to use really depends on the ALM requirements of the project and on the know-how of the implementation team. Power Platform pipelines provide a simple UI that helps makers deploy managed solutions without deep development skills, but it also continues to evolve and get more and more features in it, such as of recent, the option to deploy directly from source code. All target environments used in these pipelines must be enabled as managed environments. Power Platform CLI is a simple command line interface to perform various operations in Microsoft Power Platform. It supports export and import of solutions, working with environments, and more. Build tools for DevOps GitHub Actions are built on top of the Power Platform CLI. They act as building blocks to configure a custom ALM process that fits the needs of the organization. Pipelines can be set up through a UI, while the YAML is generated automatically in the background. Custom pipeline can be used by organizations that need more control and flexibility over ALM, but also requires deeper developer skills to create and manage pipelines. It allows full customization for complex requirements such as integration with legacy systems. The trade-off is higher maintenance, more complexity, and stronger governance requirements. As a best practice, production environments are kept secure by not granting elevated access to every maker or developer. Granting system administrator access broadly makes it difficult to track who changed what. Deployments should therefore be executed using a service principle. As mentioned before, the performance of solutions import has been recently improved. But to take advantage of this improvement, it's necessary to understand the various options available throughout the tools and know which one to use. In green, the stage and upgrade option. The stage and upgrade should be used instead of the two-stage import as a holding solution. The stage and upgrade option refers to a single stage upgrade process. This method is faster and recommended as it supports performance improvement. It involves importing the solution and performing the upgrade in one step, which is more efficient and reduces downtime. Don't use the import as managed solution option. This option is deprecated, and it also has been removed from the PAC CLI. It was intended to convert an unmanaged solution to a managed solution during the import process, but it's not needed anymore. Just import the managed solution and it will do exactly the same. Using it during import of an unmanaged solution is not recommended at all. This option replicated an old API behavior for the early days of the platform, which is no longer necessary and or respected in current practices. Avoid using the override unmanaged customizations option. This option forces the import process to override any active customization in the target environment. This option slows down the import process and it's generally not recommended. This option does not even affect components that support merge behavior like forms, sitemap, ribbon, app models, and does not even delete the active layers. The recommended approach is to prevent unmanaged customizations in the target environment from the outset. To help with controlling unmanaged customizations in your target environment, consider using the feature Block Unmanaged Customization in Database. Don't use the Publish Customizations option for managed solution. It is only needed for unmanaged solution and should not be used for managed solution, as it would slow down the deployment. Before closing, one last consideration. Some components are not solution aware. This means that they cannot be added to solutions. Example includes skill-based routing rule sets, queue configurations, countries, region, currencies, business unit teams. Even though these components are not solution aware, they can still be moved between environments by using the configuration migration tool. And this tool can also be integrated into pipelines. This slide provides link to the documentation used throughout this session. So thank you very much. And yeah, we will publish this in 1 or 2 weeks on the portal. Thank you.
Yeah.
Bye.
Thank you.